Hello everyone, I am Amran Kamil and today our presentation on Fortress Kernel and architectural history of Windows NT security. Actually we will talk about the Windows except until Windows 11. We will explore the evolution of the Windows NT kernel from its earliest version to the modern version, hardware isolated core of Windows 11. The evolution is a story of deliberate response to an accelerating threat landscape. While many users remember Windows 7 fondly, the underlying NT kernel has undergone a profound transformation, moving from a stable but platform to earliest hardware enforced secure core. We argue that this makes modern Windows objectively uh, superior from an OS design perspective. We will have Windows XP here, and the date start from 2001. This was unification milestone, bringing the NT-kernel stability to the consumer market. Except provide architectural benefits through 32-byte primitive multitasking and protected virtual memory with pair process address spaces. The NTS file system with access control list ACLS. We have a fundamentally permissive security model, user model, and kernel model. The design created critical vulnerabilities, no mandatory address space layout randomization, SLR, optional data execution prevention, DEB, and under-secreted kernel mode driver access, making it highly vulnerable to rootkits and buffer overflow attacks. And we have the first was our built kernel patch protection, and from this point my friend will continue.
Hello everyone, my name is Abdullah Bereket. Today I am going to continue where my friend stopped, which in slide number 5. The first major security walls were built with Windows Vista. This slide shows the introduction of kernel batch protection, or we can call it batch guard, as you can see here. This was a direct response to the rise of sophisticated rootkits. Batch guards use cryptographic checksums to verify the integrity of critical kernel structures. As you can see here in this picture, this is a normal operation, and this is tampering detected, which we know the blue death screen. So let's continue with the next slide. As you can see here, if batch guard detected any unauthorized modification, a sign which means a sign of rootkits, it deliberately triggers a bug check or a blue screen, which we see like there, blue screen of death. Blue screen of death. This prevents the rootkit from resisting and causing deeper damage, effectively halting the attacks, which you can see here. So let's continue with the next slide. Here in this slide, as you can see here, Vista also introduced other key defense. What does it mean? Mandatory ASLR, and deep, which we know to randomize memory location, and the Windows driver frameworks to improve driver reliability here in Windows 7. Windows 7 then refined these systems, optimizing performance and achieving the balance that made it so popular. We all know, who don't know about Windows 7. So let's continue with the next slide. Here, we are continuing from the Windows 7 to upper Windows 8. Windows 8 laid the groundwork for the modern fortress with secure boot. This feature enforces UEFI firmware validation of the bootloader signature, ensuring the operating system starts in a trusted state. This was a necessary step to enable the next level of security features. So thank you. My friend will continue the other slides. Thank you very much.
Thank you, Abdullah, and I may continue now. Okay, the inner sanctum, the VPS, virtualized base security. With Windows 10 introduced virtualized based security, VPS, which uses the Hyper-V hypervisor to isolate regions, even on a non-virtualized system. This establishes two virtual trust levels, so VTL1 and VTL0. You have the secure kernel, a highly privileged minimal environment that hosts the critical security components, and VTL0, which is the normal kernel, runs the rest of the operating system, including the standard kernel and the drivers. Communication between VTL0 and 1 is strictly mediated by the hypervisor. It's an option you can enable in the BIOS. Kernel mode malware in VTL0 cannot access or compromise VTL1. So, here we have visualization of how it works, and HVCI. Okay, HVCI is a security feature powered by VPS. HVCI, which is hypervisor protected code integrity, uses a hypervisor and hardware in virtualization feature like Intel VT and AMD VI. These two are virtualization technology by Intel and AMD to enforce strict code integrity policies onto the normal kernel, which is VTL0. Now, we have an unsigned malicious code trying to run into the VTL0. It asks for permission. System checks. It's an unsigned driver. So if it's a signed driver, it will pass. If it's unsigned and not validated, it will be rejected. Now, defeating advanced exploits with control flow enforcement. Modern Windows uses both software and hardware to prevent attackers from hijacking programs' intended execution flow. CFG, a software mitigation mitigation introduced with Windows 10 that validates indirect function calls at runtime to prevent them from being redirected to malicious code. So, hardware enforced stack protection was introduced was with Windows 11, and it integrates CPU level features to defeat return operated programming (ROP) attacks by maintaining a protected read-only copy of the call stack. Now, for Intel CET, which is x86 architecture, we have shadow stack, and ARM architecture, we have pointers authentication. Now, with the standard stack, here we have standard stack. We have the gadget, malicious goes, gadget, and then to the return address and goes back. And we have hardware enforced stack. We have the CPU in between, the shadow stack and the normal stack. Shadow stacks checks here, it's checking a read-only copy, so it cannot edit it or anything, so it gets rejected. Now here we can see the security updates and features in NT kernel and when they were released. Now we have patch kernel was introduced onto 7 and was allowed in 10 and 11, so it goes with all of these. Mandatory ASLR and DEP was introduced with 7. Secure boot, control flow guard, and VPS HVCI was all introduced with Windows 10. And we have hardware enforced stack protection was introduced with Windows 11. Now, secure boot was introduced with 7, but this was more widely supported by 10. Now, here we go to the NT kernel of Windows 11. We've had a lot of updates into the security, and we've got trusted boot now, VPS, HVCI, and hardware enforced CFI. And trusted boot, it ensures it starts in a non-good state, no problem, no errors. And VPS isolates sanctums for security decisions. It isolates a file and asks you, do you want to keep it or run it? And HVCI prevents unauthorized code from running ever running in the kernel, like unsigned code. It will be checked, unsigned, rejected. And hardware enforced CFI protects it from execution, protects execution from hijacking. Here we can see Windows XP was the unification. Vista was kinda bad, but 7 was an improvement of Vista. It was the foundation of this. And with Windows 8 we got trusted boot. With Windows 7 we got VPS and we got HVCI. And with 11, hardware CFI was introduced. Thank you for listening. This was the NT kernel through the years, and we've seen how it improved through the years. And crazy how XP how we went from XP to 11 with better driver support, driver optimization, security, and cloud-based security. Thank you.